All right, welcome back, y'all. This is our second video on equilibrium. Shout out to everyone who liked and viewed the previous video. Please like, share, and just leave any comments if you have any questions. All right, so equilibrium. Equilibrium is when the total linear force, or the forces that are going up and down or left and right, is completely equal to zero. All right, so imagine if you're sitting in a chair, you're in equilibrium because you're not moving. Okay, so equilibrium pretty much means no movement. Okay, equilibrium, especially when you're talking about with weights or things hanging from bars, like we have in this problem here. Okay, you have some type of circular force, or you have what we call torque. Okay, tau is the symbol for torque, and whenever you have something in equilibrium, the net torque is also equal to zero. Okay, and that makes sense because it's not rotating, it's not moving. So whenever you're dealing with equilibrium problems, especially with torque, you always want to try to first figure out what are the forces linearly and what are the forces angularly. So in this problem, we have a bar that is suspended by two cords. All right, I have cord A here, and I have cord B here. Okay, and on this cord is a bar, some type of bar, and attached to the bar are two weights. Okay, we have mass 1 and we have mass 2. M1 is 0.8 kilograms, M2 is 1.1 kilograms. All right. And we also have to account for the weight of the bar. Okay. So the mass of the bar also has some type of weight. The mass of the bar is 0.1 kilograms. Okay. So with that being said, we see that we have a lot of forces pointing down. If we continue doing our free body diagram, we have the weight of mass 1, and this is, so let me make sure. So this would be the weight, but this also is a mass too. So it has a mass, but the weight is pointing down. So the weight of the bar is also pointing down. And then you have the weight of mass 2. Okay. Now, Newton's third law says every action has an equal and opposite reaction. So we know that this is an equilibrium because it's not moving, because despite we have these three forces pointing downward, we also have these two tension forces up here. We have tension B and we have tension A, which thus creates the equilibrium where the linear force is equal to zero and the linear net force is equal to zero, and the total net torque is equal to zero. Okay, in this problem they want us to calculate the tension. Okay, so previously in the other equilibrium problem, when we calculated the tension, we had to create an equation and solve for those missing variables. So that's what we're going to do. Okay, so we always start off with the linear forces, the forces going in the x and y direction. Okay, so starting off with the net x forces. So starting with the net x forces going left and right, we can see here that there are zero forces going left and right. So we don't really need to care about that. The net forces going in the y. Okay, so we have TA, which is positive, plus TB. Okay, we have the weight of, we have the weight 1, which is the weight of that mass block, which has a mass of 0.8 kilograms, minus the weight of the bar, minus the weight of the second block. okay? Because it's in equilibrium, the total net force is equal to 0. So then therefore, we can see that we can solve for these forces here and create some type of equation with the tension because we don't know what the equation is, okay? So we know that the acceleration due to gravity is 9.8 meters per second squared. And the weight equation is mg, depending on the direction, negative mg, okay? So if I just multiply each one of these masses here to calculate the weight, I can further develop my equation. So we see that weight one is going to be 0.80 times 9.8 plus 0.10 times 9.8 plus 1.1 times 9.8. And that gives me a total of 19.6 newtons. And if I do a little bit of math, I add that on both sides. I now have my first equation to figure out my tension. TA plus TB equals 19.6 newtons. All right, so we have this equation now. Let's try to figure out another equation, but this time we're going to use the torque, okay? So again, torque is just the angular force. So we can see here that I have my radius here, my radius R, bar, that's my bar, okay? Torque is pretty much the force between a bar and another force going perpendicularly, okay? So we can see here we have these perpendicular forces going perpendicular to the bar, okay? And if we were to say push this down, it will create some type of clockwise motion, okay? So imagine if this tension wasn't here, the bar would pretty much rotate in a clockwise motion because it has these weights, right? And so we have to account for that direction. So we call that positive, we call that negative torque. So negative tau, let me make this a little bit lighter. So negative tau is when it is clockwise. And positive tau or positive torque is when it's counterclockwise. Okay, so when we start our total net force equation, we're going to account for that direction. So we can still see our picture here. So now we're going to do the total net torque, okay, which we said was 0. But now we have to account for the torque of tension A, right? Because if this wanted to point up, this will make the bar go the opposite direction. So this also has some type of torque. Same thing with this tension here, okay? Because it's perpendicular to the radius of this bar, therefore there's some type of torque. So we have torque A plus torque B, and both of these are positive because this is counterclockwise. We have the torque from the weight 1, and that's counterclockwise. We have the torque from the bar. And then we have the torque from the weight 2. Okay, so now we can calculate the torque and figure out and see if we can get another equation like we did here. So we know that the total net torque is equal to 0. Let's figure out the torque at each one of these points. Remember, torque is force times the radius. And that's where these numbers are going to come in now. So the torque at A, so the force at A is TA, that's my force because tension is a force, times the radius. Well, the radius at this point is actually 0 because it doesn't extend out, it goes straight up. So then therefore, this is going to be 0. So therefore, there's no torque at A, at TA. Plus, all right, we have the tension B, excuse me, because that's the force, times the radius. The radius is 100 centimeters, and SI units, that is 1 meter. All right, so we got that one down. Now let's do the weight, okay? So we know that the weight is going to be the mass times the acceleration due to gravity times the distance. The distance is 20 centimeters, and that in SI units is 0.2 meters. Okay, so that torque is going to be 0.8 times 9.8 times 0.2. That gives me negative 1.57 Newton meters. All right, the weight of the bar. The weight of the bar is the same thing. I do the negative 0.10 times 9.8 times the distance here, which is 0.5 or 50 centimeters. And that's going to give me a torque of negative 0.49 Newton meters. All right, and then I have the torque from this mass here, mass 2. So that torque is going to give me, if I do the multiplication, negative 1.10 times 9.8 times 0.60. That's going to give me negative 6.48 Newton meters. All right. So if we finish out this equation, I have 0 equal to TB minus 1.57 Newton meters minus 0.49 Newton meters minus 6.48 Newton meters. And if I do that math, that's just going to give me 0 equal to the tension minus 8.54. Okay, and you can see here that I have another equation. So the key point when you're solving for tension and equilibrium is you want to create at least 2 equations that has one of the other variables, and you can just do the algebra to solve for the other. So we can see here that TB is equal to 8.54 newtons. And all I have to do is plug in that in this equation to figure out TA. So I got TA plus TB, which is 8.54 newtons, equal to 19.6 newtons. Solve for TA. You're going to get TA is equal to 11.06 newtons. And so I now figured out the tension A and tension B from that equilibrium problem. all using the total net forces in the X and Y direction and the total torque. Okay, so please leave, share, a comment. Thank you so much for paying attention. See you all soon. Thank you. Bye-bye.